So this is the day 2 of the workshop. Yesterday we had day 1 where we had paper presentations online, and today in morning we had official opening ceremony of the conference, followed by a tutorial on trustworthy AI by Dr. Anantaram. And this is the second part of the conference. So today, now it's afternoon time in India, so very good morning. And our students are coming, and we can start the workshop. So I would like to introduce the speaker of this workshop, Dr. Constance Theory. She is going to deliver her workshop on the title Modeling and Exploiting Imperfect Data Using Theory of Belief Functions. Dr. Constance is an associate professor at the University of Rennes. Professor Constance research focuses on modeling and analyzing data from imperfect sources of information using the theory of belief functions. She teaches computer science at IUT de Lyon in various subjects: artificial intelligence techniques, databases, analysis, and theory of computation, and so on. So with this brief note of welcome, I would once again welcome Dr. Constance. So it's your time. Please continue with your talk. Thank you so much.
Thank you very much for the introduction. Okay, so my workshop is about how to help you to modelize your data with belief function theory. So a big part of the workshop will be an introduction to the belief function theory. And first I would like to know a few more about your knowledge on the belief function theory. So if you could please scan this QR code or go to Klaxoon. I don't know if you know Klaxoon, but it's a way to make survey and to know a few more about your idea of the theory. Thank you very much. With your smartphone or your tablet, Friedrich. Is it working for you?
Yes, ma'am.
Okay.
So everyone has to answer.
Yeah. That will give me an idea about your knowledge about belief function.
Kindly connect with the server. You can scan this page, a QR code.
Sorry, but it's complicated to hear because it seems that the microphone is maybe far away from people speaking now. Ah, okay. Okay, perfect. Thank you very much for that. Okay, so I have some people joining. Frederic, could you tell me how many people approximately there are in the room so I could know when it's okay, I have all participants or not? Okay. Okay. Okay, thank you very much.
Students, please scan this QR code with your phone and start your survey. Please scan this QR code with your phone.
Okay, is it working? Could you answer the survey?
Yes, ma'am. It's working.
Okay. Okay. Mm, mm, I'm looking for the results, but oh, okay, it's okay. Okay, so I have 26 results. So, oh, okay, but for knowing about the belief function theory, it's nice. You could see also the results normally.
Pas encore. Tu le partages pas ensuite.
Okay.
Tu es toujours à partager le sharing the QR code.
Yeah? Yeah, but it's for the people
Yes, yes.
coming. But normally at the end of the survey, you could see all the results if you click on the right thing.
I have the assembly of code.
Okay. Okay. Okay, I will stop sharing this one and I will share the results to see. Okay. You could not access. Okay. So, if we have a look at the results, are you aware of the belief function theory? So, there is approximately inequity between people knowing a little and the other one totally or never heard about it. So I will make the introduction of the theory for people who don't heard about it and for those one who know a little that will increase your college. Well, I apologize for people knowing totally the belief function theory because the courses will not bring you a lot of new information, but we could discuss application at the end of the courses. Okay. So do you distinguish between probability, mass function, belief function, probability function? 12% totally, and the other one not really or not at all. So it's okay. That will be interesting to discuss these functions. Okay, it's nice to see that you don't know a lot about the different combination operator and belief function theory because I have a big part of my presentation about that. And the last one, okay, perfect. So a part of you know how to make decisions using belief function theory. Nice to know it. Okay, so I will go back to the courses. Okay, so this is introduction to the belief function theory is based on some other work of my colleagues from a school of belief function given in 2019. If you are more interested by the theory, there are other schools organizing 1 year on 2. So this introduction is based on Thierry Deneux and Arnaud Martin courses. I will introduce you the belief function, and then we will discuss some combination in the belief function theory and way to make decision. I will give some example of application in the case of my work, and then after the courses we can discuss how to help you maybe to introduce belief function theory in your work if you are interested in it. So in computer science we often have a lot of imperfect information or imperfect knowledge, even more with the big data and for example the use in neural network or more recently in LLM. The data could be different, such as from sensor or human expert or models. And there are different ways to be imperfect. That could be by ambiguity, inconsistency, uncertainty, or imprecision. In the case of my work and with the belief function theory, I only focus on uncertainty and imprecision. If you are not totally aware about the difference between them, I will just make an introduction of that. So the uncertainty in all cases could be a random uncertainty, so such as a throw of dice, or an epistemic uncertainty. The epistemic uncertainty reflects the source's knowledge of the subject of the question. Here you have an example where, for example, we asking people what species is visible, and maybe some people are going to say it's a tit and it's a certain information because we have knowledge about it. And other one with less knowledge will say that maybe it's a tit and they are more uncertain. In case of imprecision, so this characterizes the information content of an initiation. So still with the bird photo, some people are going to say it's a tit only, which is more imprecise as the other people saying it's a blue tit, given more information. Okay. Currently, we often modelize the uncertainty with the theory probability. So I will not develop because it's a famous theory, so you have the model with a function in 0, 1, such as the sum of the function is equal to 1. And you can combine thanks to Bayes' rule and take decision on the maximum like you would, for example. But there's still some limits in this theory. Here is an example. Consider 3 athletes, and they are going to perform a race. And okay, a current question is who will win the race? So you have 2 commentators. The first one is going to say all 3 are at the same level, and the other one I really don't know. And then when you use probability, you modelize the both answer in the same way by an equiprobability. But it's not the same assertion. So we have a problem with the probability theory is that equiprobability and total uncertainty are represented in the same way. And this is something that we can solve thanks to the belief function theory. So we have also other more flexible theory compared to the probability theory. You have the imprecise probabilities and the possibility measures, but I will not develop both of them. I will only focus on the belief function theory that you could also know such as the Dunster-Sheffer theory. Okay. So, for the belief function theory, you have a frame of descendant, omega, which is composed from classes or hypotheses that are exclusive and exhaustive. And belief functions are defined on 2 power omega into 0, 1. So on 2 power omega, you have different interesting elements, such as here the empty sets, which symbolize the open world. So that means that if we have a masses on these elements, that means that the information considered could not be represented by the hypothesis of the class. It's maybe something else. We have also omega that symbolizes the ignorance here. So if we go back to our previous example with the athletes, for the commentator who don't know which athlete is going to win the race, we should put a masses on omega. So we have 3 interesting functions: the mass function, the belief function, and the plausibility function. I will explain both of them. First, the mass function. It's the elementary degree of belief from 2 power omega into 0, 1, and the sum of the mass for an information is equal to 1. If we are in closed world, that is to say that there is no possibility for another information, the masses on the empty set is equal to 0. And the elements x into a power omega, such as the masses of x is not null, is called a focal element, and the meeting of them is the kernel. You have a specific mass function, so a Bayesian mass function is the equivalent of a probability distribution. A categorical mass function, which reflects a complete certainty of the sources, and if you have a categorical mass function with a focal element, where the focal element is omega, then the sources is fully ignorant. You have also simple support mass function, where you have an element x of omega, and the idea is that the sources believe in x, but not fully, so the rest of the masses will be put into the ignorance, and the other masses are equal to 0. Then you have the minimal belief, which is the belief function, Bell, and the maximal belief, the plausibility function. So you always have Bell lower than the plausibility PL. So here is an example. In my work, I have performed a crowdsourcing campaign, and I asked contributor what species a bird belongs, giving them a photo, such as this one, and some bird names. Here you have an example, and I ask them their certainty, and then I transform the certainty into a numerical certainty, so into a mass. So in this example, the frame of descendant will be the bird names answers. And here, for example, the contributor has selected carrion crow, European jackdaw, or common raven as an answers. We'll put a mace on the answer, and as he is totally certain, it's a categorical mass function. But imagine that the contributor choose, for example, that he is only certain. We will have a simple mass function with maybe a mass of 0.8 here and 0.2 on the ignorance. Also, an interesting fact in the belief function theory is if you don't fully believe in the sources, you could weaken the masses by a coefficient alpha, given this equation. Weakening increases the interval between belief and plausibility, and that is going to decrease the conflict resulting from the combination of belief functions. So this could be an interesting operation. For example, I use it in the case of crowdsourcing if the contributor, in my opinion, has not a lot of expertise for the task, and the expertise is computing in some other ways. You have also a possibility of refinement or enlargement of frame of descendant. So, for example, with the bird names, you could say that it's maybe, if I show you a bird, it's maybe a bizet pigeon, or, okay, I haven't said the name of pigeon, sorry, we'll take the tit. So it may be a blue tit or a green tit. And if you have less knowledge, it will be a tit for you. And you can go from one frame of descendant to another one thanks to refinement and enlargement. So that could be interesting too if you have data on one frame of descendant which is close to the other ones. You could bring more information and gather more information if you are going to move from one frame to another one for combining information. So I will now introduce different type of combination. Okay, the easiest one is to make the average of the masses. But you have also conjunctive, disjunctive, or mixed rule of combination. For the conjunctive rule, the combination requires the source to be reliable, distinct, and cognitively independent. You have the equation of the conjunctive rule here. This rule is interesting because it reduces the imprecision on the focal elements and increasing the belief on the concordant ones. There are different properties, so the rule is commutative, associative. For example, there is another, the more interesting fact for me is that thanks to the conjunctive rule, you can see global conflict appearing, and this conflict is on the empty set. So I think it's really interesting. So for example, in crowdsourcing, I could see this, if the question is difficult thanks to the global conflict, because there will be a lot of different answers and the global conflict will increase. Here is an example of conjunctive operator, but such as some of you already know it, I will not develop a lot how it works. I will give you the presentation. I don't know, Frederic, if this could be put on the website of the conference, maybe? Okay, thank you very much. So in this example, in this exercise, you see that we have one masses, M1, well, for example, one contributor in crowdsourcing, and the contributor believe that the answer is omega 1 or omega 2 with a masses of 0.7, and for the rest he is ignorant, so he chose 0.3 on omega. And we have another contributor omega 2 with the corresponding mass function. The interesting fact is that such as the two contributors disagree into the information, we observe a conflict appearing here. And another point which is interesting is that the union of elements disappear, such as the information of the singleton is increasing. So if you don't want to have conflict, because it's maybe not useful for you, you can use the normalized conjunctive rule, where the global conflict is distributed on the different focal elements. But there is still a problem that is given by the ZADE example. In the example of ZADE, we have a patient who has an illness that can be caused by 3 factors. And we have 2 doctors. The first one believes that it's more likely the omega 1 factor that causes illness. He does not, he is not absolutely certain, and there is maybe a really little possibility for omega 2. And at the contrary, Dr. 2 believes that it's more likely to be omega 3 with a little possibility for omega 2. And so you have the mass function here, oops, corresponding, okay, yeah, here. And if you perform the conjunctive operator, you will see that there is a lot of conflict. But if we take decision, we are going to choose the omega 2 factor. And at the contrary, with the Dempster conjunctive rule with a redistribution of the conflict, we have a value of 1 for the omega 2 factors and no conflict. In both cases, the decision will be taken and the corresponding elements will be omega 2, whereas for the doctor it was the less probable elements. So we have a problem with the redistribution of the conflict for the conjunctive rule on this way. That's why we have also other proposition for redistributing the conflicts. You can distributing it thanks to Jaeger rule, for example, or Inaga-Kirk rule, eliminating the conflict by not using a conjunctive rule but a disjunctive one. And you could also have a partial distribution thanks to mixed the rules who mixed conjunctive and disjunctive rules. And you have finally the fourth closed word assumption, where you are going to say that you stay in open one by adding a new element in your frame of descendants. And sometimes the new element is just, it's totally something else, but there is not more precision about it. For the Jaeger rule, you use a conjunctive combination, and the conflict is put into the ignorance. The idea is to say there is no conflict, there is only ignorance in the case of this combination. Okay, and for Inagaki, you have a distribution of the conflict thanks to a weighting of it into the different focal elements. But you should take care of the weight taken. The disjunctive rule is interesting in the way that you should have at least one source reliable. So if the other ones are not, it's not really a problem. You have a total loss of the conflict, but also a loss of specificity. But that will be interesting if you want like to expand your focal elements. So we have another exercise with disjunctive rule. We have two mass functions. So you see that at the origin you haven't any mass on the union of omega 1 and omega 2, for example, and after combination a new mass appears. That's it. And if we take some mixed rule, such as this one of Florea, for example, we have the sum of the disjunctive and conjunctive operator for the same mass functions and same frame of discernment, and they are weighted by some coefficients given here. You have also the mixed rule of Dubois and Pratt, given here. And so that's it. So after combination, we are now going to take decision, and we have different ways to take decision in belief function theory, considering the plausibility of the belief. Or we could come back to a cradle way. Sorry, we can come back to probability with a pygnistic probability. So for the plausibility, it's the same equation that I have introduced before with the plausibility function. And you could choose, for example, the first one with the maximum of plausibility. It's an optimistic decision. And in the case of pessimistic decision, you could choose to use the belief functions. Which is more selective. And then we have the pygnistic probability, which is a good compromise between the belief masses and plausibility masses. The pygnistic probability is given by this equation, and you are going to take the maximum of probability. Okay, this is another exercise to take decision with the masses that I had obtained previously thanks to the disjunctive operator. Here we could see that we have a different value of the results for the decision according to the belief, the pygnistic or the plausibility. But both of them are going to give omega 2 as the good element, the good hypothesis. So that is for the courses, the quick courses on belief function. Now I will give you some example of application. Okay, I had worked into a linear project named EdWork. A linear project is a French national project. EdWork is a crowdsourcing platform. You have here a QR code to know a few more about the project. Our objective was to define an expressive workflow to model and capture different crowdsourcing scenarios for complex tasks. Currently, EdWork is online. If you are looking for EdWork and crowdsourcing, normally you could find it onto your browser. Here you have the link if you're interested. In EdWork, I propose to use belief function to modelize the human answers. Here is the schemes of the platform. So we have a participative crowd or a rewarded one with a factory named week who perform tasks. And we could use belief function to model the answers given by them at this point. We could also use belief function to estimate user skills. I don't know the size of the screen for you. Could you correctly see the graph?
Yes, we can see it's big screen.
Okay, thank you very much. So, here are some works where we have models and aggregate contributions thanks to the belief function theory. We had received lots of contribution on crowdsourcing tasks on the WIRC platforms. It was bird crowdsourcing campaigns once again. So you have a yellow curve here and a brown one. For this one, we use belief function to perform the aggregation, increasing the size of the crowd. And the pink curves is for traditional aggregation in crowdsourcing, which is majority voting. So you have the good answer rate. So we compute the good answer rate We compute this rate after the combination by observing if the selecting answers thanks to belief function or majority voting is good or not. On this graph, we use only precise answers. In this one, we use imprecise answers. So on the first one, contributor could select only one bird names. On the other one, they could select one or more bird names. We observe that we always have a better result for the belief function theory compared to majority voting in both cases, and even if the answer was precise. Here are some references about this work. If you are interested in belief function but you have not data to trade, as we have performed different crowdsourcing campaigns collecting real data, we give them to the community. So here you have a QR code. They are on the Big Fast Society website, and you could use them to compute mass function or plausibility, credibility function. That's it. Another idea of application could be in education, for example. I'm supervising a thesis on the modelization of human learning through imperfect responses. The idea is that with online courses, you have a distance between the teacher and the learner. And it's not easy for the teacher to estimate correctly the knowledge of the learner. That's why we propose to use belief function to have a more accurate information of the learning as a current instance T. And to do that, the response to the MCQ are modelized by belief functions, and the good response expected is modelized by a belief function too, and we compute the distance between the good answers and the student answers. And this is interesting because we could give several good answers with different level. So we could, thanks to this distance, estimate different level of knowledge for the students. And then there will be a processus of recommendations, still thanks to belief function. Another interesting thing about this work is that thanks to belief function, you could have a mass into the ignorance, and we will represent the learning of a people by moving the part of the mass of the ignorance on focal sets. And that's it for some example of implication. I will enjoy to discuss with you about your idea or your use of belief function. So this theory is really useful to modelize imprecise and uncertain information, but you should be really careful defining the frame of discernment and the model that you would like to create. Okay, and if you would like more information, you could find it into some school or conference of the Belief Function and Application Society, for example. I give you the link of the website here. On this website you have also software and toolbox and the imprecise and uncertain dataset that I had tell you. And there are also a lot of other interesting things on the in this theory that you could discover thanks to the school. For example, vacuous extension, marginalization, decombination, distance, and other things. Thank you very much for your attention, and I will enjoy to discuss with you your idea of using belief function in your work, or if you currently use it. Thank you. I don't hear you. Oh, it's okay.
I have some questions.
Sorry, could you go a level up with your microphone, because I don't.
I have some questions. Can you hear?
Yeah, but it's a few low, maybe.
Yeah, I have some questions. Can you hear?
Yeah.
So, Aminar Khan, thank you very much for your talk. I just was not sure whether I understood carefully. Are the omegas independent or with no overlap? Is that an assumption in your work, or it's not that omegas? Is it that the omegas need to be independent or with no overlap? What if there is an overlap found later?
Sorry, I haven't really understood the question because the sound is not really well.
Ma'am, can you hear now?
May,
Are you here?
yeah, thank you very much. Sorry, Frederick.
Yeah, I just wanted to ask, are the omegas independent or they can be, they can have overlap?
They're independent. I said it here. Okay, they're exclusive. What? Have you an example in mind?
Yeah, what I think is sometimes it might be that omega 1 and omega 2 have an overlap which is found later, in the sense that it may have an overlap, we are not sure, but we assume that they exclude. I just wanted to ask what happens if omega 1 and omega 2 are both, I have some belief on that, and but they have some kind of overlap. What will happen in that case?
I don't know because I don't really see how they could overlap. Because for me they are really different and exclusive. I think if they're overlapping, it's much more as the union of two hypotheses.
Okay, so can I give a small example? For example,
Yeah.
let's say I have symptoms, okay, and I'm diagnosing a patient, and I say it could be flu, it could be common cold, it could be COVID. I mean the COVID. I mean, in the sense that I'm just trying to diagnose as flu, common cold, and then COVID. So there is an overlap. We are not sure because the data is may not be sufficient. What if there is an overlap? That's what I wanted to know. Because then I'll have belief that okay, I pay say 0.6 for common cold, 0.7 for influenza, and say 0.55 for say COVID. I'm not sure. So I just wanted to know what happens in that.
For me, your hypotheses are not overlapping. In this medical cases, it's not the hypothesis that's overlapping, but the definition of them into the information. So there is no problem. But I think that depends about the masses. And then I don't see any problem to having these three elements into omega, such as their difference. You could, if you are interested, have maybe a refinement from one frame to another. If you could say, for example, some diseases are dangerous and other one less, and you can have some of things like that. Maybe that could help you.
Okay. Okay, I'll think about that. So this is a tangential question. If I can ask you a question slightly out of context, the rough sets theory, which was proposed by Zizitslaw Paula, is also about imprecision and discernment. When you were talking about discernment, I was thinking about rough sets theory, which talks about classifying information based on imprecise membership of functions, membership of sets. So would there be any help from rough sets theory into this as more information comes in? I'm not sure. That is an open thought which was going in my mind when you were talking about, in a sense, some kind of a membership with the omegas and discernment.
Sorry, I haven't correctly heard the name of the theory you say.
Rough sets. Rough, R-O.
Could you write it, please? On the last set?
Rough set. On the chat, it was like a rough set by Bridget.
Check.
Rough set. R-O-U-G-H-C-S-E-T.
I will have a look because I'm not really aware.
Okay, there's one more question which I want to ask, which is also interesting to me. See, there is a lot of work on belief maintenance, that is truth, ATMS and JTMS, that is assumption-based truth maintenance systems. Because see, we are talking about beliefs, and beliefs can get revised. Okay, so omega 1, omega 2, omega 3 are the theories. I mean, they are putting some belief in those derivations, right? There is as more data comes in, I might revise the beliefs. So we have all these things like assumption-based truth maintenance systems and justification-based truth maintenance systems, which are to maintain for belief revision. Have you thought about, is there any use of that in this?
No. Sorry, I haven't belief revision in mind. I had performed some crowdsourcing campaign where we are asking contributors to refine, for example, their answers, and then we modelize it this not really a change of belief, but such as you ask a refinement, you have a little change because they are less certain. We modelize this thanks to consonant mass function. Consonant mass function are mass function where the elements are nested. So you could have for closed focal set different belief. So this could be a way to revise maybe belief, for example. But maybe you could just also creating, maybe, for example, a mass function. And if you would like to estimate a change of belief, create a new mass function with the new belief of the people or the sensor, if it's sensor, and compute a distance between the two beliefs to estimate the change of the belief, for example, things like that.
Okay, thanks. Thank you very much. Thank you for your answer.
Is there a question?
Is there any questions?
Questions have.
Just I want to thank.
That's all.
No questions. Just I want to thank. Hello, Dr. Constance.
Hello.
Yes, yes. I am Dr. Rajkumar, one of the co-chairs for the conference. So we would like to thank you for spending your valuable time to come online. So thank you for your time and the skills that you have shared. And the session was very much useful to the students, and they have learned many things about belief networks. Because in our bachelor's and master's curriculum, we have probability and the statistics course, but we don't have, we haven't yet introduced belief networks, and really it was very much fascinating to learn how uncertain information can be represented with belief networks. So on behalf of the students and the organizing committee of ICODIUM 2024, we would extend our heartfelt thanks for your time and the workshop. The workshop has been a great success in the conference, and if any students, if they want to know a little more about belief networks, and we would get back to you with email queries. So thank you once again. Have a good evening. Thank you.
Thank you very much.
It's morning. Yes, good morning. Yes.
No, it's no problem.
Yes, true.
Have a good day
Yes,
and enjoy the rest of the conference. Thank you for the invitation.
Yes, thank you. Yeah, next year we would like to have you in Bishop Heber College and delivering workshop face to face.
Thank you. It will be
Yes.
maybe easier compared to online
Yes.
presentation.
Yes, yes.
Thank you very much.
Next year it will be end of January.
Sorry, Frederick, I haven't heard you.
Next year it will be at the end of January, the conference.
Okay.
Yeah.
Okay. Thanks.
Thank you.
Thank you very much.
Merci, Constance. À bientôt. Une bonne année.
Merci, bonne année à toi aussi.
Les étudiants reviendront vers toi avec leurs questions en ligne.
Ouais, j'avais peut-être pas compris. Je pensais que en fait ça allait être plus d'échanges. Mais c'est peut-être compliqué en distanciel. Hein.
En fait, le souci c'est que en fait, comme on sait les étudiants et on n'avait pas prévu ça partent en 8 jours de vacances.
D'accord. Ouais, pas de souci. Par contre, c'était un peu compliqué avec le micro. Ça me faisait comme un écho en fait pour comprendre ce qu'il se disait. C'était en fait là, je t'entends bien, tu vois, mais avec le micro, c'est. Ah oui, c'est pour la salle. Ah mais moi, ça hachait beaucoup. C'était un peu compliqué avec le micro, mais juste pour t'informer pour les si t'as d'autres visions. Ça se passe bien? D'accord. Oui, donc ils étaient pressés de partir, ça marche. Ben, bonne fin de journée, merci beaucoup pour l'invitation Frédéric. Et on rediscute prochainement. Ah ouais, avec plaisir. Oui, j'étais pas prête. Je sais pas si mon YouTube va supporter mon anglais. Merci pour tout, c'est très gentil. On se revoit. Au revoir.
With heartfelt gratitude, I thank every esteemed chief guest and the speakers for their valuable thoughts on AI and all the diverse fields. So thank you students for your kind cooperation. Students, your refreshments are outside.
Thank you.
அவ்வளோதான் ஜூஸ் கொடுத்தாச்சு முடிஞ்சிச்சு அப்படியே கொடுத்து அப்படியே அனுப்பிச்சு விட்டேன்